Okay, so it's streaming. Do you have any questions? Natasha, really fancy view. Can't hear you.
I was thinking about telling or not telling where I am, and I decided to keep it in secret.
Okay. Good choice, since it's streaming on YouTube. So do you have any questions? It could be any question. So it could be not connected to, for instance, instrumental phonetics at all. But maybe weather is a bad topic, I think. Okay. So maybe I'll try to start. 9 students for some reason looks... I expected more students, but maybe I'm too expective.
For some reason, I don't know why. Maybe it's just me. I was thinking that today will be the course with Damian Blasi, but now I looked in the timetable and now it is course with you. So I'm just, I'm adjusting my brain from evolutionary linguistics to phonetics. So now I am, yeah, I will. I don't know. Maybe someone is like me waiting there, but no, in timetable.
It's on Thursdays, isn't it? Today's
Yes,
Wednesday.
yes. So I just mixed up. Maybe I'm not alone. Maybe I'm alone. So I don't know.
And Sasha, this kind of saying that you said, it's really interesting. You switched your brain from evolutionary linguistics. You didn't have any classes yet, yeah. Aren't you?
Yeah, but I was preparing myself, So
Oh.
I was telling myself, okay, so tonight I will know something about evolutionary linguistics, and wow, so it's phonetics. So I did to to prepare myself for phonetics. Yeah, but
so, go on.
Yeah, and so I just don't. I don't know. I forgot what we were going to discuss after we discussed last time the animal linguistics, etc. So I just don't know what to expect today. So perhaps my only question is what is going to be today. So what we will discuss today.
Okay. So today, a plan for today is to discuss vowels, and only them. And then I have a small seminar. And for this seminar, I guess I would like to have some. So I would like to present a package for R. So I actually expect that you have R Studio on your computer, and that you can put there something like install packages. So let's say install packages from this oh no, stop sharing chat. This command, because it will install it or it won't, so we will know in advance. So this is the plan today, to discuss vowels mostly. And actually I have some feelings that I expect that during the evolutionary linguistics, you'll have some kind of phonetics and phonology part. It's all I expect. So, but Damien Blasi is a really nice speaker, so I will try to attend with you. Okay. Do you have any other questions, thoughts? Maybe no. Okay. So let's try to start then. I will share my screen. Probably remove this. And here I expect that this should be somewhere here. Here, here, here. So as you see, I prepared this presentation 2 years ago, or even 3 years ago, and didn't change much. Yeah, but we'll discuss some packages probably. Yeah, more packages. Okay, so today vowels. Last time was bioacoustics, and before this we discussed what do I have? More or less. So so I have previously worked like in like in born serials. We have this previously on this top. Um, we had so we described sound waves, and we actually discussed this harmonic motions. So these ideal waves, and discussed that sounds could be represented with sign formula that can so this amplitude, fundamental frequency, phase, and time. Then we discussed Fourier transform, briefly discussed without any deeping down what's going on there. And I forgot to send you a link to the nice video that actually give you some feelings of what's going on there. But anyhow, we had this, and then we discussed that all actual sounds are actually complex sounds. So we need this Fourier transform in order to decompose complex sounds into the simple one. So that's why we have Fourier transform. And then the first lecture actually ended with this kind of plot that I call source filter model, where we have this airflow and harmonics produced by our vocal cords. Then we have a vocal tract, and it's filter out some part of those harmonics, and then as a result, we get something like this. And during previous lecture, I hope that I showed you how to tweak a little bit some features of the spectrogram in order to make it visible. So in order you to see either harmonics or more broader view, like here presented like this one, that we will call formants in several minutes, I think. There is also some links over here. I think this. I can't remember. What is it about? I think larynx is about what's going on in larynx, and vocal tract filters some frequencies. This is okay. This is MRI speech. Okay. Anyhow, so here you have some useful links. Maybe we'll watch them one day. Okay. Maybe even this MRI is actually a nice video to look. So let's. Maybe it's somewhere. It should be here. Oh, here is a path. So it should be here and here.
You wish to know all about my grandfather. Well, he's nearly 93 years old. He dresses himself in an ancient black frock coat, usually minus several buttons. Yet he still thinks as swiftly as ever.
This is a really long video. Do you hear it? Good, good. So one important thing is you actually had this task about reading some chapters about articulatory phonetics. And the important part is over here. Do you know what's going on here? So, right, right.
A long flowing beard clings to his chin.
What's going on here? Could somebody? Is it possible that somebody will explain me what's going on there?
It's stuck to stop the airstream came from the nail, nail like the hole, but from the mouth.
Yes, exactly. I think I agree totally with what you said. So here is the uvula. They called uvula. So during the speech production, in most cases, it will actually stop airflow to go to the nasal cavity over here. So this is the main idea for this uvula. And also it's nice to look what's going on with the tongue. So take a look over here.
Giving those who observe him a pronounced feeling of the utmost respect. When he speaks, his voice is just a bit cracked and quivers a trifle. Twice each day he plays skillfully and with zest upon our small organ. Except in the winter when the ooze or snow or ice prevents, he slowly takes a short walk in the open air.
And so on and so on. So as you see, actually tongue have two parts. The tip one that doing something, and they are actually can work more or less independently, but they definitely depend on each other. But here they play around with their like doing different things. So here is a tip: when you point somewhere and do something, and body that you could be that you move backward, for instance, or forward, like here. Oh, this is clear. So this is backward. So the whole body is going backward and down. And this is the front position. So it's going like front. Okay. So sometimes this is going on in our vocal tract. And the idea that those movements of the tongue somehow correlates with the vowels that we produce. So if the tongue position is more or less front, then you have high front vowels like E, E, and so on. When you have movement backward over here, over vellum, it will the person will produce sounds like oo or something similar, or maybe. And it's possible to go down there, and then it will be ah. Okay? And the neutral position, what's going on in the neutral position? Jonathan, may I ask you to answer?
I'm afraid I don't understand neutral position. Do you mean neutral position in the tongue? In the tongue?
Yeah, when you don't, so you don't move your tongue anywhere, but you produce some pressure with vocal cords. What will be the sound? You can try it yourself. That's why we have mics.
It's the ones that vibrate. I'm not sure, to be honest. I'm not completely sure.
Okay. So I actually expected you to do something like means than you think or something, but you actually don't do anything with your tongue during this position. And in most languages, it will be just simple schwa. So that's what I wanted to from you. But anyhow, sorry, it's everything okay, so don't worry. So the neutral position is schwa. And this is the main theory behind this, I guess. And here is the IPA chart for vowels that we have. So again, front position E, schwa in the middle, A or is down here, U or is over there. So more or less correlates with the so where this person looks. What do you think?
Where she does what?
Sorry, I can hear you.
Where she does what?
This person who pronounced those vowels. Imagine that this is a person, and this somehow correlates with the tongue position. So where this person looks.
To the left.
Sure, to the left, exactly as the person that pronounced so in this video that we just watched. So this person looks over there. Okay. But here is the vowels. So I guess you can play around. If you don't know what to do with these weird signs, you always can do something like this. Vowels, IPA chart, interactive, and then you get something like this. And then you can do something like and so on. But you get my idea. But actually, it's possible to do with the consonants.
Ra, ara.
What do you want to hear? For instance, this.
Ha, aha.
Oh, I disagree with him. Actually, I would expect ha, something like this. Ha, ha. But anyhow, let it be. Yeah. So
Ra, ara.
this is better. So you can use this chart in order to get those sounds and have a feeling what's going on there. Okay. I probably will try not to forget to put the link in on the course website, so you have an ability to go there. But historically, this chart appeared first, and nobody actually cared much about tongue position, acoustic features of this tongue position, and so on and so on. So this chart is just impressionistic linguistic construction that we start to use, and then we attached acoustic theory to this. So here, all those charts, and we'll try to work with extreme positions. So E, U, R are actually extreme position, and it's easier to work with them because when we talk about E, it's possible to show it like something in the middle between E and R. There is actually a huge spectrum itself, but it's possible to try to figure out what's going on there and what will be acoustic features of this item. Okay. So far so good, I hope. So here we have those faces. And those faces, for some reason, look in the opposite direction. So there are small faces and the big face that looks leftward, as we decided. But those faces, for some reason, looked right to the right side. So here is the vocal cords, epiglottis, uvular, and this is the tongue position. So during the E production, during the E production, you have something like tongue position is near the palatum over here, so the hard part in your mouth. And so it's up there. In order to produce ooh, it actually moving backwards. So you have here some constriction over here near velum. So this is the if this is the actually so palatum is actually bone over there, and the velum is actually a soft space of behind this bone. So in order to produce E, we need to go it back up, and then here it's the body position is up and back. And in order to produce R, you need to have constriction over here. So it's like, sorry. So it's like more like backward than upward. Okay. And this is simple articulation model, nothing fancy. What we have as a result, we have different format structures. So those kind of filters that we see over here. What kind of why I call this a filter? Because filters are going from here. So here is the simple example with schwa, actually, because it's 500 and 1500 and so on. So vocal cords position. So here is tongue in the neutral position, and as we discovered with Jonathan, that this is the exact position for schwa. But when you move your tongue position, then this filtering function changes. And the result of this change is represented with these charts. What can we see on this chart? We see that so there is a first peak on all these graphs because, and this is like relict result of the analysis. So don't care much. So what we care much is about the first peak over here. This is the first formant that we call formant. And this is a result of this filtering. And this is the second formant. So for E, because all those pictures correspond, so here is E, here is the picture of articulatory picture for E, and this is formant picture for E. So E will have something like smallish first formant and bigger and really high second formant. When we talk about ooh, the result will be that again it will be a smallish first formant and smallish second formant. And when we talk about the first formant is not so smallish, but distance between first and second formant is not so big. And here is some numbers for you to not to be lost. So here is the, I didn't wrote hertz here, but it's actually 300 hertz and 2300 hertz. So for O, we have 300 hertz and more or less 800 hertz. And for R, it will be 700 hertz and 1400 hertz.
Sorry, may I ask you a question?
Sure, sure.
So actually, what the tongue does, in fact, it changes the form of the vocal tract in order to change the relative position of harmonics.
Yes, exactly. That's what I meant. Yes.
Oh, okay, thank you.
So in neutral position, when we don't have any changes, the distance between first and second and actually third harmonic is more or less the same. And this will be around the first filterish part will be 500 hertz, then 1500 hertz, and so on and so on. When you change your tongue position, you increase, for instance, for E, you increase this distance between first and second formant. When you move your tongue backward, you doing the opposite thing. So you decrease the distance between first and second formant. And when you move your tongue backward. So over here in this area, you're just shifting everything to the right. So it's not 500 hertz, but it's something like 700 hertz or something. Okay, but yes, thank you for the question. It's exactly what I want you to have a feeling of what's going on. Okay. The one thing, so the one reminder. So here we have these idealized vowels. So this idealized vowel that don't care about gender, don't care about age, don't care about, I don't know, anything. But this is actually, you could treat it as a big lie. So we have those values, but those values in order to you to have some references. But the actual truth will be looks like this. So this is a vowel chart drawn in Prot, as you see. Sorry, drawn in R, as you see. Maybe it's hard to see, but anyhow, it's drawn in R. And here we have each dot is represented with a letter. And this letter represents the vowel. And this vowel represents a value on the formant space. So here on the x-axis we have second formant, and on y-axis we have first formant. And you also may notice that those axes are somehow reversed. So here the first value is 1000 hertz, the next value is 2000 hertz. So you can find that it looks like it's ordered from left to right. And the same with the first format. So it's ordered from top to the bottom. So this, what you achieve if you analyze real vowels. So this is data from Hillenbrand et al. And I guess this is the American, yeah, it should be American vowels. There is a smallish trick that actually, so there is a little lie behind this plot, but more or less it will give you the impression what you achieve when you analyze vowels of real people. Do you have any questions so far?
This data, it's about pronunciation in different positions or by different people or by the same person at different times.
Yeah, actually, I think you have a star for me. So this is a really good point. So that's what I meant when I said it's a little bit lie, because ideally I would like to have this kind of plot from one person and in more or less the same position. Here, I actually merged together a different pronunciation of different people. But if you want to look at some real data from split it by person, I think I can think what should I share? I probably it's here. Maybe here, maybe here, maybe here. There it is. So this is a plot from Abaza speakers. For some reason, I have only 3 of them, but actually I had more. So the idea is more or less the same. So each vowel corresponds to, each point corresponds to a vowel. There are some vowels that phonologically treated as a combination. So for instance, here we have this E, but it's phonologically treated as I. So the combination of schwa and Y. And the same over here. But as you see, this will be your result. And there is a schwa everywhere, all the way around. And you also may notice that those schwas, actually all sounds, for some reason have different size. So for instance, this is a smallish schwa and this is a huge schwa, like Hebrew schwa, I don't know. This corresponds to the duration of the sound. Okay. So
Yeah, thank you.
So really nice point. But I have more reliable data, but they will be look more or less the same.
So it is one person and different words, yes?
Yes.
Like I invert, I don't know, корова и молоко. So it.
Yeah.
Okay.
It's a little bit more tricky. So because I think that here is the plot of all one syllable. So all those words are one syllable words. Yeah, but yeah, and the idea will be, and there is no any молоко in Abaza, but anyhow. So the main thing that I want you to note is that the structure of this system will be more or less the same. When I'm saying the structure, I mean that there is a schwa, there is a a, there is u, there is o, there is e and e, and so on. But the real dispersion of those schwas could be different. So, for instance, as you see for D11 over here, vowels are really dispersed according to the first formant. Here is the first formant values over here. But here, for instance, all other speakers are not so dispersed, so they are more compact and so on. Again, schwa over here is a little bit dispersed, and it's not so dispersed within second formant over here. Yeah, something like this. So this dispersion could differ from different speakers. And sometimes there are clear mistakes. So here, for instance, it's more or less clear that this schwa is not actually a schwa. So it's a mistake of automatic formant detection algorithm. So this should be corrected. Okay. Do you have anything else? No, we don't have any interesting. We don't have any interesting stuff here, but this is what you will achieve. So here I said you, and with this, and now I expect that for E, the first formant will be 300 hertz, and the second formant will be 2,300 hertz. As you see, we can expect actually to be spread through over this thing. So there is a random process that we'll see that you could see some values will be targeted. So it will be in the middle of these ellipses that are drawn over here. But for most vowels, it will be just, so it will be targets and then some dispersed around this, around these values. Okay, any questions? Cool. It looks like we can go forward. So going forward, we represented our vowels with these things, but we actually can simplify this using just simple tubes over here. So when we say E, as I said, there is some small constriction in the front part. When we have U, there is a constriction in the middle part. And when we have A, we have constriction at the back part. And that's all. So we can analyze vowels as, so represent them as a simple combination of different tubes. And this is not my idea. This is the idea from Uldish Belgodish, Fund 1960. This is really a known work. And there are more newer approaches to this, but we won't discuss it during this course. Okay, and now we need this idea of wavelength. So imagine that we have some air particles in a tube. So, so here is a tube, and there are some air particles, and we, I don't know, blowing them forward, and they start moving. And each particle actually doing something like, it's not like moving forward all over, because it strikes some other particles and go back. So as you see, you can see this pow, and then the next one is pushed, so it's go further, further, and further. And this first actually will do something like pendulum, as we had before. So forward, back, forward, back, forward, back, forward, back, forward, back, and so on and so on and so on. And this actually how we define our waves. We defined them before. And we define the other notion that is called wavelength, that is actually more or less the length of this curve from during one cycle. So again, for instance, let me maybe draw. I think it's possible to do like what? Maybe I can do it like this. Cool, it works. So here is a line that corresponds to equilibrium position. So usually we draw 0 over here. So we can do something like this, 0. That's all. This is 0 value. So there are also, maybe change the color to something like this. There's also, maybe I need to do, no, it doesn't work. And this way, no, it doesn't work. This way, no, okay. So let's assume that I will draw it like this. So there is those guys. How do we call them? Red one.
So is the amplitude?
Sure, Vanya, sure. This is amplitude value. And this corresponds to maybe not Vanya, but somebody else. Rahmat, may I ask you, what is correspondence between amplitude and some our impressionistic feelings about the sound? Rahmat? Okay. The next person I want to call, I wanted to call Ina Zibir, but then I found out that she's a teacher. So maybe Tanya?
Can you repeat the question, please?
What is the physical, so what is the correspondence for amplitude with our physical impressions of sounds? So if, for instance, there are two sounds and one have greater value of amplitude, what do you expect it to be if you press play?
If the amplitude is loud, bigger, then I think this sound maybe it's louder.
Yeah, exactly. So it will be louder. Oh, no. Okay, so this is correct. Cool. Thank you, Tanya. And oh, okay. And maybe Aisha, may I ask you another question? What will be correspondence with the frequency? So how fast this wave oscillates within the second?
I'm Aisha, by the way. So you
Okay,
don't-
sorry, Aisha.
That's okay. So I guess frequency.
So there are two waves. Again, the same story. There are two waves of the same amplitude, but one have a higher frequency. What do you expect them when you press play button?
That maybe impulses of certain sounds would be the interval between them would be shorter, maybe if we need frequencies.
No. The length of this sound is the same. It's I don't know, 3 seconds.
Huh. I think I forgot, but I'm not sure I remember.
Okay, it's not. Don't worry. There is also. Oh, this is the name I've didn't have any people for ages. I haven't seen people with name Aleftina. Is it Ala? It's short.
Yes, Ale is a short name. So frequency of waves.
Yes.
I think it influences the highness or lowness of the sound we hear.
Yeah, more or less with the pitch level of this. So if we have higher frequency, then I expect that it will be of the higher pitch or higher note or something like this. So another notion. So we discussed the length. So what is the length during 1 second? So this is a frequency. We discussed amplitude, that is reddish over here, and we need the some new notion that is called wavelength. So it's actually, let me try to draw with the pen. Is it possible? Should be. Maybe mouse? No. Mouse is just a mouse. Okay, maybe like this. And maybe I don't want to do it with the red, but I want to do it with the green. So here, maybe I need to change this to this. Okay. So here is the line that appears. Blah, 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 blah. So this is one cycle. Sorry for cousin drawing. So this is the so the length of this line in green is called wavelength. And this will be a little bit important for our next discussion. So is it clear what is called wavelength on this drawing? So this is a length of the wave within one cycle, but this is the length in the terms of these movements of the line itself. Okay? So is it clear what corresponds to wavelength on this graph?
And how call the half of this, like the lower half and higher half, like below 0 and above 0? So is there a name for the half of the wavelength?
I don't think so, because actual waves will looks like this, and this is a cycle. So I know it looks like a drawn signature, but this is a length, so it will be just some something like this and then repeat it multiple times. So maybe there is, but I'm not aware of such a name. And remember that real waves don't look like those oscillation beautiful creatures that we are working with, but they are looking like this. Okay. So maybe clear all drawings and then go out. Okay.
It's measured in microseconds.
No, I don't think so. Since it's length, it measured in centimeters or I don't know.
Oh yeah, I meant centimeters. I just was looking at the formula.
Okay.
Yeah, okay.
So here we have speed of the sound. And this corresponds to wavelength and period. And the speed of the sound will be around this 33,400 centimeters per second. So why do we need this? This number will be important for quite time.
Sorry, I have a question.
Yes.
Before you ask Aisha the question, when the frequency rise, how does it change about the waves? How to compare the two waves? But here the C is a fixed number, so the frequency rise, and so the wavelength just decrease, and then the wavelength decrease, and then the period also decrease. I think.
Sorry, could you repeat, because I somehow didn't get the question.
You asked Aisha to compare two waves. If the frequency rise become bigger, how does it change or something?
So you're asking how this value
No.
will change?
You see the wavelength doesn't change, but I think from this, because the C is fixed number, if the frequency change to bigger, so the wavelength will be shorter, will be smaller. And when the wavelength become smaller, the period also becomes smaller.
So maybe I will try reformulate, because so the wavelength could become smaller. So for instance, imagine that we have two waves with the same amplitude, but with the different frequency. So for instance, one is 100 hertz, another one is 200 hertz.
Because this is one equal, how to say that? I don't know how to say this. Say equal to this, because it's already done. It's already fixed. So when one element changes, another will also change, because they need to make the number always be this fixed number. So when the frequency changes, the wavelength will change, and the frequency change bigger, the wavelength will change smaller, change to smaller.
Sorry, I'm missing it again, but maybe you want to say that this value is fixed.
Yeah, so if the frequency change to bigger, to make sure the result always the number, so we will find the wavelength will change to smaller.
I think that you're right, but maybe I need R to show it. So the idea, maybe I will reformulate for those for others. Maybe they understood and I didn't. But the idea that this value is more or less fixed because here what we are calling wavelength is the length during the cycle. So for instance, if we have waves with the same frequency and the same amplitude, the wavelength will be the same. It's obvious. But if we have two waves with the same amplitude and, for instance, frequency will be different, the wavelength will be the same, even though the frequency is different, because we just compressing something into the smaller chunk or increasing, but the length will be more or less the same. But when we change amplitude, so for instance, we can compare two waves with the same frequency, but with the different amplitude. So one is louder and another is quieter. Then what we expect then? So this value is, so maybe we had this during in our classes. Maybe here. And where it is? Right here. So over here we had something like this. So compare wave 1 and wave 1 plus wave 2. They have the same frequency, but they differ in amplitude. Yes? And the idea that here wavelength should be greater than here, even though the time and frequency is the same. Are you agree? Danshu?
I think the amplitude doesn't matter to what I talked before, because you see the amplitude, if we just consider the first wave, the amplitude is 1, and you can draw a wave just also with the amplitude with 1 up, but the period is shorter, the wavelength also be shorter, and it just because of the frequency to be bigger. Just to, how to say, to push the wave to a shorter period. Just like, just means the frequency become bigger.
For me, what Wanshu is saying just follows from the formula you showed. The formula for the speed.
This one.
Yeah. I think that Wanshu means that if we increase frequency, then the wavelength should decrease.
If we
that's
increase,
probably.
with the same, if the amplitude is the same.
Yeah. Probably.
Yeah.
Okay. So imagine that we have this one. So here wave 1 and wave 2 have different frequencies.
That's the example I want to describe.
But the idea that we analyze one cycle, so for instance, from this to this, and from this to this, And when you increase frequency, will be, so we have this movement, and the question is whether it will be smaller than this. And according to this formula, you're saying that it will be, so if you increase frequency, the wavelength decrease. Is that what you wanted to say, Anshu?
Yes.
Okay, it sounds reasonable, but I'm not sure that it's true.
I think you should believe the mathematics in their life.
So, because here we have more or less the same wave, and the difference from this is just compressing and increasing this. So why this movement? So this movement should be longer than this one, and that's what you say. So maybe I will agree. Yeah, I think that I agree with you over here, and this is yeah. Sorry for long. So sorry for taking it so long for me to understand what you're saying. So I needed this value, 33,400 centimeters per second as a speed sound, as a some value, because afterwards we will analyze our vocal tract as some kind of tube. And this tube is, for instance, imagine for a moment that this tube will be this kind of length. So it will be 70.5 centimeters and 1 centimeter in diameter. So we just think that this complex something over here could be represented as this one. And after this, we can actually get the formula. So using this value, we can analyze. So getting frequency back using this lambda that is a wavelength. But here we multiply it by 4. Why we are doing this? Because when our vocal cords are vibrating, what you see is wave is actually should be compressed twice. So this is a closed tube. And imagine that we are blowing to the one open part. So if you have a wave, in order to get, so since wave, only those waves that go inside and go outside will be resonated. This how we can calculate the lowest natural frequency at which such a tube resonates. So if we have this kind of tube like 17 centimeters and a half, then multiplied by 4, and then we divide this speed of the sound by this value, then we more or less achieve this 477 hertz, or around 500 hertz. And the idea that this will be the first format or first resonation frequency of our tube. And also the tube will resonate at odd multiples of that frequency. So we get more or less this value that we've seen earlier over here. So 500 hertz, 1,500 hertz, 2,500 hertz, and so on.
Sorry, may I ask you a question?
Yeah.
So, in fact, it doesn't matter that, like, the natural tube in the vocal tract, it's not like, well, it's in some places it's wider and well, it's not homogeneous, I'd say. So the only thing that matters is the length of the tube, or not?
If you go into the physics, actually materials are matters because different part of the vocal tract are actually consist of different, let's say, flesh and bones, because different flesh and bones have different resonation frequency. So in the ideal model, we need to consider this. But for modeling purposes, we just ignore this. So we ignore. So we treat it as a simple tube with the more or less homogeneous resonation frequencies.
Okay, thank you.
So this. So here we have the tube also resonates at odd multiples y, and here is a simple explanation. So when we have 500 hertz, so this is a 500 hertz, and then we add. So we have multiple harmonics, and there will be also 1000 hertz or 1500 hertz. But when we have this one, so here is the 500 plus 500 hertz. And here is the graph that we see over here. But if we have 1000, it looks like it will be overlap. So there will be part like this one that overlaps. So as you see, it's possible that here will be peak, and then nothing, so smallish oscillation, big oscillation, small oscillation, and so on. But when we have odd multiples, we actually will interact with it different ways. So for instance, here we have peak, 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 so peak, 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 and so on and so on. So this idea that we have with these multiple odd multiples is that actually when we add those waves, the problem is that in the even multiples, it will somehow cancel itself. So if we use odd multiples, we can use them and obtain our next frequencies. So here will be 5 hertz. Here will be 1500 hertz. Here will be 2500 hertz, and so on and so on. So it will be n multiplied by 5 hertz. Okay? So here will be 1, 3, 5, 7, 9, and so on and so on.
Just to make it clear, so in fact, the only thing we do with our like tongue is change the length of the tube, well, in an abstract way.
I didn't get the question, but the idea will be that, for instance, people with the shorter tube, let's say, with the shorter vocal tract, will have different different values. So it will be not 500 hertz, but for instance, 450 for shorter tube.
Oh, okay. So it explains like the variation in speakers.
Yes, yes, that's the idea.
Okay, thank you.
Okay.
May I also ask a question?
Sure.
But it can be super stupid. Why this tube is closed? So it's only for I don't know, for sound that are produced with closed lips.
Not lips.
What if it's
not lips?
uh,
Here we have vocal cords at the beginning. When vocal cords are open, so when they open, so we'll get we'll get much huger. So it will be hard to model, but then you will need to include all lung subsystem into the story. And when vocal cords are open, is actually it's a little bit different and less resonative. because part of the air goes to the lungs. So we are only interested in those cases when vocal cords are closed. So they are oscillating, but in the position of the, when they closed, they make it possible to vocal cords to resonate.
Okay, I just was thinking that we like produce the air from the open, and maybe it was like misunderstanding. So air comes from the closed end, and then it closes, and the wave vibrates in the tube.
So so we have lungs, and then we breathe out some air. Then we make our vocal cords to connect to each other in order to them to vibrate. And they have two positions when they vibrate. They have two positions. Either they opened or they closed. But those vibrations are with some really huge frequencies. So for instance, 5 hertz. Oh, sorry, 500 hertz. Let's say it's too high, sorry. Let's say to have 200 hertz. So it looks like that they oscillate, so they produce this opening and closing position, but with this frequency of 2 hertz, so it's really fast. And during this position, when it's open, there is a huge system with lungs and so on and so on. So this all we need to take into account. When it closed, it's just it's closed, and then we have this tube, and that's what we
Okay.
are. Okay.
Yeah.
Cool.
Thanks.
I really like those kind of questions. Yeah. So we've spent 1 hour and 10 minutes, 9 minutes. What do you think it is?
Those are 4 months,
Yes.
but it's all I know about.
No worries. It's okay. We haven't actually discussed formats, so you don't need to know it in advance. But we actually discussed, but somehow fast and tricky. But yes, on the spectrum, it will looks like this. So blum, 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 blum. Each part is the separate format. It's actually really irregular. And if you look here, it will be starting from, so this is, so 1/10 part will be over here. So it's actually 500 hertz, 10,000 and 500 hertz, and so on and so on and so on. So it's exactly what we discussed. If you listen, be prepared. Maybe it will be too loud. So this is what we get. Sorry for animals again. But we have this. So what's happened? This is actually question. This is actual spectrum of cat meow. So don't worry, I'm not cheating here. And this is exactly the spectrum of this cat meowing. So what do you think?
Could you repeat the question, please? Because I forgot. Yeah.
Yeah, it's a little bit stupid because what I'm asking is what's happened, and this is like this is strange. Could you explain why do we have so regular things when the cat meows?
Because the cat doesn't produce any vowels, it just like schwa. It
Yeah,
can configure its vocal cord in any way.
I think the last. Could you repeat the last part?
I mean, it can't. The cat can't change its how it's called. Uh,
It
it's
cat.
mouse. Yeah, it can change the position of the tongue, for example. So it's always like a schwa.
Yeah, this is exactly what I wanted to hear. So cats, poor creatures, actually have the problem with the moving of their tongue. So body of the tongue is not much moving. Actually, the tip of the tongue is super cool. If you ever seen a cat drinking, it's really what they're doing. It looks weird. Looks really nice. So, but with the body position, so what the whole story that we discussed during the video that I've showed at the beginning, when human produce different speech sounds and move uh, her tongue forward and backward, cats can't do that. What they can do is just having this schwa. But then we have a question. Why in all languages over the world, cat meow represents with M and W or U or something like this at the end? The exception probably is Japanese when we have meow, or how do you call it? Or maybe just nya. I can't remember. And I think you've heard it yourself, aren't you? So where it is? It's not here. Close it. What do you think is the source of this u or w at the end and m at the beginning?
So I keep thinking of how cows are sort of also, they don't really produce the m sound, I think, but we also say like moo for them. And I feel like this is a pattern, which I didn't really know how to explain, but I feel like it's when people hear them produce these sounds, it's maybe easier for them to imitate them when, maybe no, maybe I'm wrong. I just feel like there has to be, it's harder for us to reproduce the sound they're making if there is no like um, there is no consonant in the beginning, but I think that's the stupid theory.
Oh, Aisha, I really appreciate what you're saying because it's actually a reasonable way of thinking. Um, I actually worked in Dagestan and they have a lot of different things, but I think in all the Dagestani languages that I worked with, there was a uvular sound. So uvular sounds is like r, and so on. So they actually had something like r. It's not r, it's r. And they, what I'm representing now, it's something like trillic. So r. Sometimes there is a some miss. So there is a myth about French that they have the sound they don't anymore, and so when you hear Edith Piaf doing something like and so on, that's the sound. But the actual sound is like and in most, I think in all languages of Dagestan and Adyghe, I think it's Adyghe the same, they represent dogs barking with the rau. So it's something like this. So sometimes when you have some sounds in your system, then it more like precise, but this preciseness is different. And actually, when it's really nice that you said about cows, because what they're saying is something like and sometimes they open the mouth, and maybe sometimes they close mouth, and the same with the cats. And the effect will be more or less the same. That's what I wanted to hear from you. Oh, there's a chat. They're doing something. Okay. Mm. Okay.
What about the sound with the French, the trilling French sound that they don't have anymore? It sort of reminded me of Edith Piaf. How
Yeah,
she's
yeah, yeah. Actually, I said about this, but it looks like the now French people used to say "r" itself, so they don't use like or something. But this is so. What I'm pretty sure that all people in the world, when they represent cows and cats, what they actually perceive is something that these animals produce their sounds with the closed mouth that actually corresponds to, in most languages, is something like this. So what you're doing, we suddenly discovered that in order to produce you need to just doing something like so it will be schwa, but with the mouth closed and the uvula opened in order to air go through the nose. So then you have but then you open the mouth, open your mouth, and then so for cows it will be moo or something like this, and then everything represented with ooh because lips are forward, and then all human perceive it as ooh and so on. And the same with the cats. So what they saying, they opening their mouth and then close them. And then when they close them, it's not closed enough. It will be ooh or something because it's meow or something, meow or something. So all the time it will be around this. So that's how people perceive animals. And this is another nice topic. And I think it's time to go to and have a break. So let's meet in 10 minutes and discuss further things. Okay, hello. Is it possible to ask you to type one in a chat? Cool. There are a lot of you. So please install the package. So here I send you the code. So I'm sending it again. We'll use this and probably do the same with maybe the rest. Yeah, maybe the rest is not so important for now. Okay. Okay, so I'm sharing my screen. This one. So we stop here, I guess. So I will continue with the short. So there are several slides, and then we'll come to the seminar part. So how shape of the vocal tract influences on vowels? We actually discussed this tube model, and when we have a simple tube, everything is okay. But when we have combination of tubes, it became a little bit more complex. But it's also possible to get those frequencies from our ideas about the form of the tubes. So here, so Helmholtz resonator is actually a video, so you can look at this. Maybe, do you want to do it now? So it's something when we're blowing to the bottle. Maybe we'll skip it. Just it's not so important. So as a result, we will get something like this. So this is a picture from Fant's book. When we have schwa, so it's okay to have first formant like around 500, 1500, and so on. And then just having changing something will move those formants to the left, for instance. So here we have small neck, let's say. So all formants moved to the left. When we have R, it's the opposite. So first formant moved to the left, second formant moved to the right. When we have U, so the first formant is really high, so is really low, and second formant became higher, and so on and so on. So theoretically, it's possible to calculate what we will achieve using this tube model. But there are also some other models. So they are listed here. We didn't discuss them much, but they start making sense when we work with not only with vowels, but the including some new details to the consideration. So after this, I want to discuss how to get something like that. So imagine that you analyze vowels, how to get from sounds to this kind of picture. This is actually not a long way to do this, but I actually maybe I still don't know whether I want to do this today or not. But let's see. First thing that I want to discuss with you is vowel editor. It's something that we have in Prot. So for instance, Prot closes new sound from vowel editor. This is thing that represents vowel space. So here is E, here is U, here is E. So you could type here. Oh, sorry. And after this, you will get some values. Why does it work? Okay. We can do something like cats meowing. Maybe this will be better. So we can produce something like this. We can manipulate with duration. We can manipulate with start frequencies. So it became, for instance, more like this. And maybe increase a little bit in order to get cat. So this is more like a cat. So we can manipulate with this and do something, whatever we want. And after we like something, we can publish it, and it will appear over here as a sound that we can save and work over here.
Sorry, how to open vowel editor again? Could you show me?
Sorry? How to open it? How to open a vowel editor? It's here. Prot objects, new sound, create sound from vowel editor. So,
okay, thank you.
Prot objects, new sound, create sound from vowel editor. Over here. I think we can spend 1 minute on you playing with it. I guess you play a lot because during the real classes in class, it becomes a disaster. It becomes a disaster because all students start doing something like these weird sounds from all computers in the classroom. This just sounds awful. So let's move on. What can we do after this? So how to analyze vowels. Small instruction. First, record the sound. Second, annotate some sounds. Make an exploratory analysis. Extract duration and format information from your data. Create the plot. Sounds really, really simple. This one are already solved because we have some sound and text grid prepared for you. So you can click and say you can click on it and it will save you somewhere. So please create somewhere a folder with the name vowels. Another problem, when you open a text grid, it will be opened as a text like this. It's not so interesting. So if you want to say it, you need to say Control plus S, and then save it somewhere. It's also possible to remember. It could be file, save page as, and so on and so on. Because you probably have another Internet Explorer. Am I sharing? Yes, I'm sharing. So please download some sounds and annotation.
Sorry, and if I cannot save the sound, so I'm clicking on it and it opens some like Google folder, and then it stops, and I'm clicking my right button of the mouse, and
Strange.
there is no
Could you share your
option.
screen?
Okay. So you see there is сохранить ссылку, but I don't need a link. And here there is something. I don't know what
Okay,
it
good.
is.
Press Control plus S again.
Mm.
No. This was correct, I think. So when it appears, it wants to play it to you, for you. It
So I
appears
need to
it doesn't
play.
download it. Can you press play?
Okay. Yeah. So now I see.
Okay. Cool. Maybe then you. Okay. Any other problems? And press type 2 in the chat when you finished. So you downloaded text grids and sounds. One text grid and one sound. Incredible. Six people. I think it's not so many people. Do you have any problems with it? I think there is 70 people over here. Minus 2 will be 15. I expect that minimum 10 should succeed with this.
I'm sorry, I went out for a second and then I was lost for a second. So like, what exactly?
Okay, no worries, Aisha. So what I want you to do is to go to the web page over here and download this sound and this text grid.
Okay, thank you.
And and after this, type 2 in the chat. Senior, we need to go to the course web page that is here. Hooray! No worries. I don't think it was to me. Okay, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people succeeded. So 4 people will do it in a while, I hope. So from now you have something like sounds. So you can work with it. Let's try to open them. I have it over here. So, sorry, sharing screen. Remove. So here is this I'm closing. Here's my product object. Open, read from file, and go into the folder where everything is located. Press enter, and here we are. So the last 2 sounds is actually what you downloaded. Something like this. So as you see, so we had this plan. That's why I had I marked those part as done. So somebody recorded a sound and annotated sounds. So you need to make an exploratory analysis. Extract duration and format information from your data and create the plot. I'm not sure that format script will work, but anyhow. Maybe we'll change a little bit the plan for today, but anyhow. So first, what do I mean by analysis? So let's go here and we have formant. So here we have those formants. Maybe you had it a little bit less, so standard value will be like this. I don't like standard values, so I change it to dynamic range to 50, for instance. It's better. Okay. So what do we need? First, I want to show you that there is a formant tab over here, and we can say show formant. And I hope that you will see the dots that appears over here. So if you use 1 point, so just 1 point, you can press formant, get first formant, and here is the value for the first formant. For some reason, it disappeared, but it appears. Yeah, it's doing strange things. So here it is. You can also press. So here, get first formant. As you see, it's possible to press F1 and F2 and F3 and F4 in order to do this. This is a little bit complicated since modern computers lack those buttons. And you need to press Fn F1 and Fn F2, Fn F3 in order to do this. But I actually used F1 in order to get this information, F2, and so on. And here I think we need to stop in order you to open those files and do the same job. And press 3 in the chat when you pointed somewhere and got the second format. Masha, hooray!
Actually, I'm
Tanya.
still struggling how to download it. What button should I push? When I go to the website, I can't see like the button I should push to download it.
Okay, could you share your screen?
Okay. So here it is. Do you see?
Oh, why do you? So this is. Wow.
What's wrong?
This is. You have it in Russian. This is weird for me because I know that I wrote it in English. Okay. So first, this is a package for R, and in order to install R package, you need to press install install the packages, and then you have this package for your over here. So I tap this in the chat. But for now, we are working not with the phone field work, but with the separate sounds. So if you return to the page, maybe back arrow over here, yeah. So here, as you see, you see the zvuk and text grid, and I want you to download those two. Press Control and S now.
Control. Control.
Yes,
What?
Control and S.
Control S simultaneously.
Yes, at the same time, Control and S. Or maybe you can click this button "Сохранить" at the top of your window. Maybe it will work. Oh, it worked. Oh, cool. So get back and do the same job with the text grid. So text grid. And then you need "Сохранить" again. And you have it somewhere. And then open them in Prot and find the first vowel and find the some format values for this vowel. Okay?
Okay.
Great.
And where should it be in Prat?
So for now, I can see your Prot window. So maybe maybe you can share the Prot window in order to do this together.
So you can't see my Prat window.
No. I'm sorry. Only your tabs. I already started to stalk what you're working on.
Это надо заново демонстрацию запустить. Так. And now?
Now I can see it. Cool.
So, and can you see it now?
Now, yes, I can. So now you need to open some files. In order to do this, yes, you can do it here.
Okay, now I see.
Okay.
I also have technical difficulties. I don't have a button to save the sounds and that text, but I have macOS. Maybe this is a problem.
I don't think so. Could you share your screen?
Okay.
How to do it on Mac?
So this is sound.
So in Mac, you can press Control and then the mouse, and I think it should.
Control and what?
And the мышкой, короче, нажать. Сохранить. Мне кажется, так. У меня было сохранить просто как они страницы, не знаю, есть ли разница. Попробовать можно.
И здесь тоже нет этой кнопки. Сейчас попробую. Ну, ничего.
Когда я сохраняла как-то страницу, у меня все вроде как нормально.
Хорошо, я попробую.
Мне
Ладно.
кажется, сохраняет в файле в том размере, в котором надо.
Oh, so maybe use this сохранить, save as a page, or maybe you have this command S, not control S, but command S, I think, should work on Mac.
Command and S.
Yes, yes.
Should it be like?
It's actually a standard story. So, for instance, when you see Control plus S for Windows or Linux, then on Mac it's Command S.
Should it be like this?
I can't see it. Sorry. So you shared only your one window.
Расширение веб-архив.
I don't know. Looks like something wrong.
Okay, I'll try to do it.
Could you share it again and share the whole screen?
Can you see?
Command S.
But nothing, just this sound.
It's not annoying, though. It's starting to be annoying. How do you do it? Do you have any?
But I have Windows, and I also had to press show it as save it as a page, and maybe most of us had to do it like that. Are you sure it doesn't work?
Can you share the results? So save as a page, and then again I can't see anything because you shared only your Explorer window.
This one.
Oh, those cool. So remove this web archive at the end, and then you will have.
Like this.
Yeah, and press save.
And format?
Format, I don't know. Let's have it this way. And then try to open this in Prot. Is it opening?
In where? In Prot?
Yep, in Prot.
I don't know what is Prot because maybe I didn't install it.
Are you sure? Because it looks like I've seen this on your screen. Because Prot is let me share. Share screen. Here is Prot. So this is Prot. But anyhow, maybe this is a good idea to send this in the chat. Send file. Let's go. Okay, save. Wow, maybe. Stop sharing. Chat. No. Chat. Send file. Here is the vowel, and Natasha have sent a text grid, so you can download it from chat.
Thank you. Okay, I think we can keep going. I'll figure out then what steps then.
Cool, but I think that I see only 1, 2, 3, 4, 5 threes. I want more. Sorry to be greedy. If you have any questions, please ask.
I feel like a grandma play a little bit, but I can't figure out how to. So how should it look when I open it and cross? So,
Could you share the screen? I will
uh,
see. This way.
so yes. Let me try. Can you see my
Okay, so close the script. It's not. Yeah, I see it.
this one?
Yes.
Okay.
It's not important. So then use Prat objects. And then open. Read from file.
Okay, yeah, I totally didn't see that button. Okay, that makes sense. I have a bunch of saved stuff. I guess, okay, I get it now, I think.
And then you need to change, sorry for,
No, sorry for
so you need to rename, because for some reason Mac think that no, not this one, but the next one. So text grid web archive. For some reason it's saved as a web archive, and I don't think it's a good idea.
Yeah, it does that.
Okay. Oh no.
Weird. I think this one is fine.
You sure? Let's find out.
Okay. Let me change it here. Yes.
Use text grid. Use text grid. Yeah.
Yay. Okay. Okay. No.
Oh no.
Weird.
Oh no. Something is happening. So you can open it, yes?
I guess not. I can try again. But...
Wow, something happened.
Yeah. It's weird.
Yeah, it doesn't work. Maybe download from the chat and keep looking on your charger, because it looks like it will be on charge any soon.
Wait, thank you, Gaffrey. Yeah, I think I'll try now.
Okay, so try to download it from the chat, and then maybe.
Okay.
So the problem is that somehow it changed the form of this is a common practice in Mac and actually in Windows too. So for some reason, because all those extensions that we have, so you have files, and all those extensions is just, they are useless by themselves. They are not changing anything. So you have the file, and then you can name it WAV or I don't know, text grid yourself. This is just instruction to the default programs of your computer how to open this. Jonathan, I think that I've seen that you wanted to ask a question.
Yes, I just wanted to know what we should do in the last step. I mean, I opened both of the files, but I spent some time doing it, so I couldn't hear the last step.
But let's do it together.
Sure.
So share your screen. We'll do it together.
Okay. This is what I have. I opened both of them. I don't know if it's.
Or now I can see anything, but okay, now it's good. Cool. So could you open, so like for the whole, so expand this window. Because not, yeah, cool. So first, I really don't like this consonants, or sorry, IPA charts on the right. So if you mind to go to the view, for instance, view.
Oh, sorry.
And then, no, it's not here probably. Maybe file, preferences. Oh, this is the first line, preferences.
Oh.
No worries. And is it here? No.
Show.
Yeah, it's here. Yeah. So turn it off. And
should I apply it or?
Yeah, apply or okay. I think both are fine.
Okay, great.
Cool. So what I wanted to do, for some reason, there is a word appeared here.
Oh yeah, I wrote it.
No worries. We can remove it. So what I wanted you to do is to go to the vowel, any vowel you want, and zoom in there. So for instance, select some vowel over here and press select. No, now you're, okay, maybe it's buggy. Select, yeah, but select at the bottom. Oh yeah, maybe this is work. No, I don't think so. Maybe. No. Could you press cancel? Okay, so on the bottom you have around 5. On the left, in the left corner, you have something like 5 buttons. Can you see them?
I'm afraid I don't.
All, in, out, sell, back, like this. In the left bottom corner, beneath the total duration.
Sorry.
Everything fine, no worries. Everything is fine. Over here. So here we have sell, and this is select. You can still see them? Maybe,
No.
maybe. Wait a minute. Maybe I can do some weird stuff. No. Maybe I can do like annotate. Sorry, I will drawing on your screen. But I mean these buttons. Could you see this?
Yep. Okay, I got it.
Cool. So I clear. Yeah, cool. So again, starting from the scratch, select some sound, for instance, that you selected. So press, for instance, in the middle of annotation.
Like this?
In the annotation. Not on the spectrum, but in the annotation. This is still spectrum. Yes, this is better. Okay, and then press cell, so from select. Well, it doesn't work. Strange.
Yes, it doesn't work.
So you can also press view and zoom to selection.
Or Control and N. Or it looks like something with selection is wrong. So
Yeah.
maybe, yeah, do it like this, and then this.
Okay.
Hooray! We get it.
Hurrah! Thank you.
So then I would suggest to use Format tab at the top.
Here?
No, this is a stylogram, but there is a format like pulses, formant, intensity, pitch, spectrum, and so on. So formant.
Okay, got it.
And then show formant. And then you get those points over here. Can you see them?
Yes, I do.
So now if you select one point, you can press formant again. And get first formant. Like this. And then there is a window that shows that the first formant value is 400 Hertz. And also, you can close this window. And also, it's possible to select the whole sound. So in order to do this, you need to point to the annotation. So point to the U that we have here. Cool. So you see this white part changed to a pink one. That means that the whole area is selected. So for now, we can again go to the formant and press F1. And then you get the average F1 for, oh, something happened. Wow. Okay, so it's here. And this is, as you see, so look precisely here. It's 395 blah blah hertz, and then you see min F1 in selection. since we have mean value, that means that this average all values of the vowels. And it's not one selected value,
Wow.
but this is average. And another thing that I think we can do now from your screen, sorry for using you, but I think it will be nice to switch. So could you please select the whole vowel again?
Like this?
Yeah, cool. And go to the formant. And then there is formant listing over here. Yeah.
Sure.
Here you get the table that contains time, first formant, second formant, third formant, and fourth formant, and they are in the TSV format. So it's tab separated file. So between different values is tab, so it's some number of spaces. And you can actually save this using file, save as, and then have it. And now you have a format listing from the whole sound, I think. Congratulations, you. Yeah, got that. Cool.
Great.
So maybe you can stop sharing from now. Wow, Aisha, congratulations. Also, congratulations to you all who managed to do this. This is really nice to have it. So now, maybe, how many of you managed to install from Fieldwork?
Should we press 4? Oh, yeah.
Sorry?
Should we press 4?
Actually, it could be 1. Okay, you started. Cool. A lot of you did. Okay. Looks like it worked. Okay, so maybe I will continue with some package that I wrote in order to simplify work with phonetics. And then we'll probably continue with extracting information. So for now, we'll work with duration. So I will start sharing screen. So those are files that we've seen over here. And we can extract some format values. So F1, F2, and the important thing that it's possible to do with this huge average thing. So it's possible to use format listing and get those values and save it and read it somewhere. So for now, for the next moment, I want to show you some function of font fieldwork. So font fieldwork, there is a link over here to the docs part. And it has a small part over here, but here for more details, see tutorial. And in this tutorial, there is a long list with, actually it's not, wow, this is not a tutorial because get started, that's what you need. And here you need to, here is a long text that will discuss different aspects of what we can do with this package. So just know that there is an instructions over here that you can use. And I will briefly present to you what you can do over here. So imagine that we have it installed. So after this, I somehow think that you already worked with RStudio, aren't you?
Yes, we have our classes with Ilya Shurov and Ivan Poznikov.
Cool.
But we didn't do much yet.
Okay, so in all cases, so do you know what's going on? So for instance, if I type here 2 plus 2, you will get 4. So this is the terminal. And if you type here 2 + 2, this is the script. So in order to make it work, you need to press run or press Control Enter.
This much I know. We know. I mean,
Oh, I'm happy for you. Control Enter. So in order to load some libraries, you need to do something like this. So from now, if you need to install library, you need to type something like this. Okay, so you don't need to install package all the time. This is like a lamp. So in order to make a light in your room, you need to buy a lamp. So you can buy a lamp, but then after this, after you manage to buy it and put it in your home, you can just switch your lights on or off. And this is done with library command. So after this, all functions of this library will be available for you. And what I wanted to show you was several things. First, it's possible to convert text grids into the tables. So I can use function text grid to def and then use the path. Oh, okay. Maybe I will do it like this. So set vd. Do you know this function?
No.
Okay. So set vd is actually set working directory. So in order to work with some files, you need to set your working directory. And now I'm actually using my Linux path. So after I do this, I can do several things. I think more nicely for you will be to do something like go to working directory. And here we have our vowels text grid and vowels wav over here. So this is the folder that we are working with. And in order not to write down path all the time, I use this setvd function in order to do something. So after this, I can do something like this. And this function will convert text grid into this kind of table. So we can write down as a variable. And here in my environment, there is a variable with this. And here I have a question. Have you ever discussed tidyverse with Vanya Poznikov?
Not yet.
Not yet. Okay.
Could you also repeat about setvd? So we need to то есть нам нужно указать ту папку, в которой мы работаем с файлами vowels и text grid, или что нужно сделать с этой функцией setvd?
So setvd function, as actually you can get here, is the setting working directory. So here I used the path to the files where I downloaded those files, vowels, text grid, and vowel wav. But you can use it not only with this kind of situation, but any situation. So when you want to analyze some path, you can set your working directory. And now it will be simpler for work with them. Imagine that I'm interested in duration of sounds that I annotated in this text grid. It's possible to do it in an elegant way, but what you can see from this table. So this is a table that contains 37 observations and 7 variables. And what kind of variables do we have? This is simple ID. We don't care about this. This is time start. This is time end. And this is the content of the annotation. And this is a tier. we have only one tier, so we don't care much. This is the tier name. We have only one tier name, so we don't care much. And this is the source. Makes sense to have the source because it's possible to read multiple text grids from the folder and get this information. So source, it's something like nice to have it over here. So imagine that I have a task that I want to have the table that I want to analyze duration of different vowels. So in order to do this, I will need to do what? First, I think I create a new variable that looks like this. And then I need to use content. And then I use not equal to empty, and then comma. I'm using the simple sorting. I think that something this you already done with Vanya, I'm pretty sure. Are you?
Well, it appears that not yet as well.
Oh no. How many classes did you have?
Well, I guess it was about two, like two full-fledged classes. I mean, it was one class to install R or something like this, and so we had about two classes two seminars so far like this.
Then maybe we'll spend time a little bit more. Maybe it makes sense to not discuss this package now. Then.
Was your plan like to give us? Was your plan for us to know something from our classes on data analysis?
Yes, but are you scared with this kind of? You don't. So if you don't understand this notation, I don't like to have something like magical spells. So maybe I will wait until you understand what's going on, so it will be easier.
What if you maybe? Oh, I guess it will take us a lot of time, but maybe you could just explain to us every letter, and then we'll.
Thinking about that. Yes, no one knows when we will discuss this, and maybe. Do you know that maybe we won't discuss it?
No, you sure you will. Sure you will. So, have you discussed data frames?
We had a homework on it. I remember.
We had discussed it in class.
So, data frame is any table that you that have some amount of observations and some amount of rows and some amount of columns. So, if you have a data frame, then you have two dimensions. You have rows and you have columns. So in order to, for instance, get first row, you need to type 1 and then comma, and then everything is empty. You need to type it in any data frame. So for now, what I have a huge data frame like this. And after this, I'm calling a new it will be a new data frame with the first row. It's also possible to put here some vector with some value. So it's possible to call 4, 7, and 2, something like this. And here is our table again. Clear so far? Is it clear?
I'm performing these functions, and it says text grid to df is not found, and object tg is not found. So
yes, because
should I do something?
Are you sure you loaded the library?
Yeah, I'm pretty sure.
Then share your screen.
Okay.
I guess the package that we are working with called font field work. So if you call library font field, it won't know there is font field work. Sorry.
Thank you.
You're welcome. So the idea that after we have this text grid, we want to filter out only those observations that don't have any content. Sorry, that do have some content. This can be done using this filtering. So everything that we want to call, we can create something like this is the content. So that's how I get the vector with the content values. And then I can compare each content with the empty line. And I achieve something like true, false, true, false, true, false, true, false, because this is empty and this is not. If I reverse this, I will achieve another one. So it will be false, true, false, true, false, true, and so on. And this could be used as an index over here in order to get rid of empty empty annotations that we had there. And this could be written in the second variable over here. And the only thing that we can do is duration. And I'm pretty sure that you're aware that in order to get the duration of this, you just need to use this one minus this one. So we use the time end minus time start. Ta-da! And then we have duration of those sounds. And I'm afraid that somebody may firstly try to retype in something, but I will share this with you. So here is, where is it? Chat, where are you? Chat. Here's my code. So after this, I get this duration, and actually we can plot it. So for instance, it's possible to do some simple things like plot, and then you get it. Maybe hist will be better. So as you see, there is a histogram of our frequencies, and we see that this is where I from 0.06 till 0.14 or something. And this also can be shared with you. If I remember, where is the chat? And I think it's just enough for the beginning. So if everybody can do something with it, it would be nice. Yeah. So could you repeat this code and make it work on your computer? Oh, sorry. And I wanted to ask you to type something in the chat. 5 is the next. Alexander, could you share your screen?
Yes, so I think I have problems from the beginning. So yeah, I could share my screen again.
Okay.
То есть я должен написать именно ведь свой адрес, вот здесь, свой адрес, вот папка, где у меня лежит вот этот файл, вот я его написал.
I'm not sure.
Тоже у меня не так.
First, I'm not sure that this is correct starting. So first, are you sure that you need to start in Windows with the backwards slash? I don't think so.
Нет, я просто писал как так, то есть я должен набрать слэш, да, и тогда все будет работать.
Let's check it. I think the nice thing, so use, no, start.
Так, опять, вот что он мне говорит, вот это вот такое.
Stop for a moment, and I think get vd function. So instead of set vd, use get vd.
Okay.
No, not here, but just in the console.
Can I ask now? It seems like now suddenly I forgot. What file should we? Yes. What file should it be? What file should we download?
Text grid. Vowels text grid.
Okay.
So Alexander, please use get with T, then with empty brackets, without any path in it. Empty, just empty.
Yes.
It's not empty.
Yes, and
without any parentheses, quotation marks.
Okay.
And then brackets. Yes, use it. So this how you need to specify your folder. So it need to be slashes in this direction. And then I think all rest is okay. So could you copy this C colon something from the console to the over here?
Okay.
No, not here. No. Get_vd is the function that will get your working directory. So you just, for now, you know how to write this, okay? So in order to do this, you still need quotation marks at the beginning.
Okay, so I think now it works. Yeah, great, thank you.
I can't see a plot for some reason. Oh, it's there. Cool, it worked.
I have problems. It doesn't work. But for me, it seems like this last thing doesn't work. TG duration.
Let's see.
Wait a moment. So do you see that?
I think I do.
It's like object TG2 not found.
Okay, so let's start from the setvd function again. I forgot where should you use. So you use different slashes that you don't need to use. I think that this is the same mistake that Alexander made. So remove the first one definitely because it's not Linux. And the last one. And let's check whether. No. Let's back because you are not on the 20. So could you press on the 29th line before it?
29?
29. 20. Yes. No, just one line. Then press run. What do you? S-
16.
Oh, you have RMD file. Why do you have it? I get it. So could you copy this? And press so first start with file, go up there, file, file, R script. Okay, so the next step is go back and copy code from there.
All the code.
Yes, whatever you think is important. Copy,
Install, yes. Paste.
cool. Now let's go row by row. So first row, will it work? Control Enter, Control and Enter. There is no package from fieldwork. That means that you need to install package, install.package. And then from fieldwork. So in the chat we had it.
Oh, I forgot about this moment. Okay.
In this again, and then
But
here it is.
Oh, okay. I need to stop the demonstration for it.
You don't need it.
No.
Okay, but anyhow. So copy it from the chat. Don't mix it with the file that we have over there. And then share screen again.
Так, подождите. Нужно опять в XC Instrumental Phonetics зайти, правильно?
Нет. Я послал. I've sent the code in the chat of the Zoom. In the Zoom chat, I've sent you install.package from fieldwork again.
Вот эту вот строчку, да? Последнюю.
Yes. Copy this into the console of your RStudio and please share your screen.
And copy it. So I copied it, and where should I put it? Before.
To the console.
To
the console. In the button, we have something that won't be important, so we're just installing. It's not important.
Yeah.
So I would put it here. Yeah. And then press enter. Alexander, may I ask you to send your code with the setvd function?
And now is it like fine? Should we now?
Oh, and now we see the right way of doing this. So now we go line by line. So it's on the first line. So press Control and Enter. Oh, nothing is broken, so it works. Cool. Let's move the next line. So Control and Enter. Now it looks like
Ксюш, нужно просто вот сейчас одни слэши заменять на другие, а все остальное окей. То есть у меня то же самое было.
Почему вы говорите, что в третьей строчке что-то не так?
Смотри, вот на такие слэши у тебя другой слэш. У тебя вот такой слэш, а нужен вот такой слэш.
Так, ну у меня же в третьей строчке вообще нет слэшев. Разве нет?
But the third line is they are numbered, so the first, second, third. Can you see it?
По-моему, он еще во второй не работает.
Не, про второй он сказал, что нормально ему.
So may you go to the setvd function that you have and change slashes to from the backslash to the forward slash.
Okay, let's try. Wait a little bit. Так.
Control and enter again.
Mm,
No, it's just enter. You forgot to press
yes.
control.
Uh,
Work.
and then the next line.
Yes, I hope you don't forget to press control.
Uh-huh.
Okay, cool. It looks like it have a different name. So could you go to the vowel text grid? I think Windows do some tricky things.
It is probably in TXT.
Yes, yes. Could you go to the vowel text grid at the end? Can you see it in the 7th line?
Wait a moment. Here I should go, yes?
Yes, at the end of the line.
Mm-hmm.
And then several steps backward. Yes, and press tab. Tabulation, tab.
Where is it? Где tab?
On my keyboard is under the caps lock.
This. Like an arrow, стрелочка вверх. Yes?
No. Tabulation mark.
Ну,
может быть, над капслоком.
ну, там, где две стрелочки в разные стороны.
Как две стрелочки, да.
Ага, and I should...
Oh, so it was actually TXT. It's something that Windows, for some reason, adding to all text files.
Let's then check.
Run this. No, again, you forgot to press control. Wow, it ran without the problem. That's cool.
The next line now.
The next line, it's not important, but it works. It works. And it works. No, it doesn't, because okay. Don't worry about this. It's okay. And then the rest is just press hist and then TG2 $ duration.
Can you repeat one more time?
Hist, like at the beginning of the word histogram. HIST. It's actually in the chat, so you can find it there. But you press more and then see chat, and then copy from there.
Так. Дополнительно. Hist. It should be like that.
Yes, I don't know how you did it, but yeah, looks fine, even though it's a little bit smallish, but I can deal with it.
And should I like Control Enter again? Yes.
Yeah, all the time. This is run commands in R. Cool, you succeeded. Congratulations.
Finally. Thank you.
You're welcome. So I think we'll end with this simple code for today. The only thing I want to share with you some more like code that make more sense. So after you will learn tidyverse, it will look like this. So don't look at the code, but look at the result. Here I have vowels. A, E, or no, it's something like different. No, it's okay. It's E, U, O, U. It's a little bit smallish, but you can guess. And the rest is each dot corresponds to the duration. So you see that R is longer than, for instance, E. So E tend to be shorter than R and A, and E probably, no, sorry, this is U. So E and U are really short, and or and and e are a little bit longer. U is short, and so on. So you can see those dots. We can ignore y-axis for the time being. So each dot corresponds to one observations. And this is like more insightful information about this. It's also possible to color them according to the vowel, but it doesn't matter for now. I think it's all for now. But we will continue with some scripting next time. Do you have any questions? Cool. So for today, yes.
I just wanted to say that we can use vowel editor as a graphic redactor, so we can draw something here and then press play, and I don't know, so some mountains, goats, and clouds here. So yeah, I think it is cool. Yeah, you can draw something and then know how it sounds.
This is a cool idea. Thank you, Alexander. This is really nice. Okay, so it's all for now. Again, please remember that all lectures are recorded, so you can find them in the chat over here. So here you have video, and then there will be another video. So you can press there, and here is YouTube for the whole lecture. I think it would be nice if I ask you to read the Get Started page. I'm interested in the section called Philosophy of the Von Fieldwork Package. And yes, so this is a small section. So until next time, please read this and think about this. What do you think about this? Okay.
Okay.
So this is all for today. If you have any questions, please ask. And don't be afraid that we'll have a lot of R. Even though we will have some R code, I will share it with you. So for each specific task, you will have R code. So there won't be any task when you need to create your own R code. You will need to adapt the old one to the new conditions, but the code will be more or less the same. So don't be afraid of it if you are. So see you next time. Bye.
Goodbye. Thank you.
Thank you. Bye.
Bye.
Thank you. Goodbye.
Thank you.
Goodbye.